I would like to start this presentation with a rhetorical question. Have you ever tried to optimize your enterprise application, especially the loading time? I guess that many of you here may have not. As the developers, we are often pushed to deliver the features as quickly as possible, and therefore the optimizations in our applications often goes aside. Today we are going to talk about how easily we can optimize our initial load and why this may be important. So let's start. I'm Dawid Kostka, an Angular Love blogger and bundle size enthusiast. As I am often on the go, I usually travel by train, which have a one cost. Although I love the possibility of doing something during the travel, this often is interrupted by unstable network connection. I'm sure that all of you have ever experienced that. Maybe some applications have been taking forever to load, and as a result, you are staring at the laptop or smartphone screen for around 10 or maybe 30 seconds. This is especially too long, and in my opinion, we should optimize our applications so they load really fast. So firstly, let's think what makes our applications load fast. In my opinion, before optimizing any things in our apps, we should firstly understand what may go wrong. So to mimic the poor network conditions, you have to firstly set up your DevTools correctly. Make sure that you will go to the network tab and disable the cache with enable the 3G throttling. After you do it, go to the performance tab and click that magic refresh button. After around 20 to 60 seconds, you should be able to see a waterfall chart describing how your application has been loaded. Note, if you see that for the first time, it may seem really complex, but believe me, it is really simple. All of these lines here that you can see describe a particular resource that have been loaded at some point in our website. So although these are many lines here, I would like to break this down into 3 different stages. The first one of them will be loading our HTML document, which is the core of our website. After we fetch it, we usually dispatch some other requests, for example, for our JavaScript, CSS, and font files. Once this step is done, we usually fetch some external data from the APIs. At this step, we also fetch some images. But in my opinion, the first stage of loading your data is not that important as the first 2 stages. At this point, you can already display some loading spinners and skeletons to your users, so they know that you have to still wait for just a couple of things to load. Unfortunately, this is not the case in the first 2 stages, which usually are render blocking, especially if you're working on a client-side rendered application. Just because of that the client application is rendered on the client side, the users will see a blank screen until the application will fully load. So let's think how we can optimize that. In my opinion, the first step would be to take a lighthouse check of your application. This one often will highlight many problems in it that you can optimize. But unfortunately, after you implement them, you will find that the lighthouse report often lacks many specific solutions how you can optimize your website. So for example, it will say things like you're loading too many JavaScript, but it won't tell you how easily you can decrease its amount. So in this presentation, we're going to talk about 3 main things, which in my opinion are really important to speed up your website. First one of them is going to be the server infrastructure, which stands at the core of every website optimization. Then we'll move on to optimizing font load, which in my opinion is also really important. Lastly, we're going to discuss how we can ship less JavaScript into our applications, just because the JavaScript is the largest resource in our websites. So let's get started with something that is not directly related to the code we write, the server infrastructure. In my opinion, any other optimization changes won't make much sense in case you have a poor infrastructure. First thing that you should consider doing is implementing a compression format in your application. This one can decrease the text file size during the transfer by up to 80%, which will already give you a huge boost to initial loading. Just by implementing that, your lighthouse score may be increased from 40 to 100, and believe me, this one really makes a difference. For the algorithms that you can implement on your website, you can use either ZSTD, Broadly, or gzip. Just make sure that you are using the one that fits your website the best. Sometimes we may also think about not loading the individual files again and again. This is possible thanks to the caching. This mechanism is really important just because our users don't have to load the same files over again. Note that this is possible thanks to the hashes that Angular appends to our files during the build process. You can see them right here, and they are unique on every different build of our Angular application. So thanks to that little feature, you can cache your JS and CSS files for up to 1 year, which is surely going to last you until the next release. But even those two steps are not that important in case you're targeting a global audience. In such cases, using a CDN, in my opinion, is a crucial thing. This one will make your website load fast in Japan as fast as it is loading in the United States. This is really important, especially if you target a global audience. So let's finish that DevOps stuff because I am not the best person in it. And now let's think about something that we, as the front-end developers, can do to optimize our websites. First thing that you should not be doing is using a font display block property in your application. As you can see right here, this will make the content in your application initially invisible just because your font that is at the top haven't been loaded yet. And as a result, in my opinion, even in case you have a fast application that uses the SSR or pre-rendering, it will feel slow just because you're using that little property. Fortunately, it is really easy to fix. You can do it by implementing the font display swap property, which makes your text initially visible just by displaying it with the fallback font. Although this can introduce some cumulative layout shift into your application, in my opinion, seeing some content is better than seeing your content with the custom font. Believe me or not, but this really can make a difference, and 2.5 seconds on the mobile internet connection is a really long time. But of course, optimizing our fonts is not just about the typography fonts. Often we are using the icon fonts in our applications, and these ones have often a really big problem. Just because we are using a few icons in our application, we are often loading them all at once. This can result in a very slow rendering, which can provide our users with a really poor experience, especially if you're using the icon buttons in our application. The icons are often rendered really slowly just because they often wait too much. So for example, the Google Material symbols can't wait as much as 3.2 megabytes. Believe me or not, but this is a really big amount. Fortunately, other kits are much more optimized. So for example, the font awesome kit will wait around 100 to 200 kilobytes. But in my opinion, this is still a really big number, especially if we compare it to the two packages that you're likely using in your Angular application. Guess what they are? The Angular core and Angular router. These include a lot of the code, which still weighs around 160 kilobytes unzipped. As you can see here, this one is still less than the icons that you're loading into your application. So in my opinion, this is really crucial. So instead of using the font icons, that you should be using the SVG images instead. But as you may imagine, this often does not provide the greatest developer experience that you can have. So often we can wrap the SVG images with some libraries. For example, the ngX FastSVG. This one introduced many optimization into our icons. So I would like you to see the difference between these two solutions on the waterfall charts. Firstly, we have the font icons. Here, as you can see, we have to dispatch 2 requests in order to render our icons. The first one of them is the CSS request, which then triggers fetching the font file request. This process took around 14 seconds on the 3G network connection. Believe me or not, but this is really too long. Fortunately, just by implementing the SVG icons with the library that I mentioned, we can make our icons appear instantly in case you are using the SSR. Even if you're not using it, you may still consider doing that, just because this library will wait around 14.5 kilobytes and an individual icon will wait around 1 kilobyte. This is enough to optimize your initial load and make your icons appear much faster. So as we started mentioning the kilobytes in our JavaScript, let's think about how we can ship less JavaScript. This is really important just because often we ship a lot of the JavaScript. The bigger the enterprise application, the more code we ship. And what you can see here on this waterfall chart can be just a top of the iceberg in the big enterprise applications. So firstly, I would like you to understand what is the difference between the initial bundle and the lazy loaded bundle. All of the things that I included here is our initial bundle. You can see that it is the code that is required in order to render our application. You can see that on the top, where there are the frames of our application. On the other hand, we also have the lazy loaded JavaScript files, as you can see right here. This one includes the things that we don't need initially in our application. So often, optimizing our application is just as simple as moving the things that we don't need from the initial bundle into the lazy loaded bundle. We can do it by many things, but in my opinion, I would like you to see the 3 different stages. First, the optimization that you can introduce into your application is removing the CommonJS dependencies. The CommonJS module format was created with the servers in mind, and as a result, it often lacks many optimization features, especially in the modern world applications. So just by using a single import from a CommonJS library, you will end up importing the whole library to your project. This Lodash is just a tiny case. Imagine what would it be in case you imported a big charts library into your application. This would be likely a terrible mistake. Therefore, I think we should always prioritize using the ngModules libraries, which support a thing called tree shaking, which allows us to import our code granularly. You can see this on the bottom here, where we instead imported the isEmpty function from the Lodash.es module, that is the ngModule-based library. Another example of how you can optimize the library is that you can replace the moment.js with the date.js. It is really much more lightweight and, in my opinion, will really make a difference in how your initial bundle size will look like. So in case you're planning to bring a new library into your project, make sure to check it up on the Bundlephobia website and make sure that it supports the tree shaking. So another thing that you can utilize to decrease your initial bundle size is the dynamic import function. This one will be used in cases where you don't need the code initially or you're rarely using it. So make sure to wrap your imports around all of the things that you don't need. So for example, dialogues, side menus, some parts of the state management libraries, and of course, a classic example, roads. In cases you're using the Webpack compiler, you can take a look here. This one, property Webpack chunking command, can be really useful because it will name your output file that is lazy loaded during the build process. This will allow you to name this file, and as a result, you can understand which particular file in your bundle represents which chunk in your code. But even those 2 things won't matter in case you have a not properly working tree shaking in your application. This can be a nightmare. And let's think how the tree shaking should work. So here we have a simple example. We imported a code from the A file that is placed in our utils folder into our application. As you can see here, we would expect that we only imported 2 kilobytes into our application. And this is what happens with the direct imports. Unfortunately, the real cases are not that simple. Often, in our project, we use the barrel files that prettify our imports. And as you can imagine, this can make some mess. This usually happens because our imports are no longer direct, and as a result, bundlers sometimes may not be able to decide if a particular code should or should not be included in our initial bundle. So let's take a look at the example. Here in the A, B, and C file, we export a constant and log it out into the console. In the middle, we have a barrel file that re-exports all of these constants. And finally, we import our A constant in the app component file, which then gets console logged with a message that our app component has been created. As you can see here in the output, even though we have not referenced the B and C files directly, our code includes the B and C file code. In my opinion, this is often undesired, and personally, I would not expect that these things would be included in my application bundle. Therefore, it makes me think whether these barrel files are really useful. Often they are, but they have a big cons. Just because we can write some side effects in our application, for example, console log, window writes, we can make the things in our code and not reshakable. And even if you are not writing a side effects code, like a good Angular developer, sometimes the bundler may not be able to decide to tree shake things in your application. Are you ready to pay this price just for using the barrel files? In my opinion, sometimes the pretty imports are not worth it. But what in case you're working in an XML repository where you are forced to use the barrel files in things like their libraries? The barrel files here are the entry points to the libraries, and we are forced to use them. So luckily, there's a solution to this problem. And believe me or not, this one is as simple as adding the side effects false property into our package.json. This tiny little setting enables the more aggressive tree shaking in our applications, which can directly lower the impact of the barrel files in our application. Note that after introducing this setting in my project, we managed to reduce our initial bundle size by up to 18%, which in my opinion is a really big number. So for the things that got tree shaken from our application is, for example, an auth module that was required in completely another application in my mono repository. Note that this auth module should never be included in my application at all, and I wonder what your application may include in case you're not using this tiny little setting. So as you know what this setting can give you, let's think about what it does. And it is as simple as our side effects code won't be run just because we referenced some files in our barrel files. So here, as you can see, the A, B, and C file code is no longer executed, and as a result, the B and C code won't be included in our application bundle. This is as simple as that, and personally, I would advise you to use the ngModules and side effects false property in every project. Now, I would like to move on to the next thing that I'm pretty sure most of you know really well. But do you actually know it really well? I've got a question for you, and for the people on site, raise your hand if you think that the defer block will work in this particular scenario. For the people watching us online, type your guesses on the chat. I'm more than happy to see what you think. Whether the defer block will work in this particular code scenario. That means whether the defer block will create a lazy loaded JavaScript chunk in our application build.
It won't.
It won't?
Yeah.
Are you sure?
That's my guess.
So let's see what the people online think. OK, so I see that many people online are not sure.
They said that you already imported, so it wouldn't work.
OK, so basically, there are two scenarios. The first one of them is in case you're using the Angular version above the 18.2.8. This one was released around a week ago, and this fixed this issue where the defer block would not work. In case if you have any other version in your project, the defer block will not work here. So as you can see here, you may consider why this actually have not worked. And this happens because in the previous versions, we referenced the chart component outside of the parent component imports array. In this particular case, we use it to type our viewchild query. And this messed up with our tree shaking. Fortunately, there was a fix for that. And it was as simple as importing the chart component second time, this time by using a type-only import syntax. Although it may seem weird, it actually worked. By just typing our viewchild query with the type-only import syntax, we allowed our defer to work. So as you may see here, you may wonder why actually this does matter. Unless the Angular team already fixed that issue in their project, I think that we should still take a lesson from it. Believe me or not, but optimizing our code, even though we have more powerful features like the defer block, is sometimes not as easy as placing our code in the defer block. Therefore, I think that we should always verify the changes that we make to our application. Sometimes optimizing your code is not just as simple as placing it with a defer block, and I want you to see another example that can break your defer block. I'm still sure that many people here may actually use this pattern that I call the export modules. Here, in case we import the standalone components into a module and re-export them just to prettify our import, we'll also lose the functionality of the defer block. This one happens just because the defer block does not work with the ngModules. It is as simple as that. Therefore, I think we should always use the standalone architecture, which, in my opinion, helps the tree shaking do its job even in the most corner cases. But what in case you hate the standalone? Still, there are many people here that think that the ngModules is thing that you should go for. In my opinion, this is not the thing that you should be having in your application. There are two reasons. First one of them is that the ngModules will be eventually deprecated, and the second one is that the standalone feature will get many other features in the future. So, for example, one feature that is coming to our standalone components is the warnings on unused imports in our components. You can see it here on the right bottom, where in case we would not use the bar directive or the full component in our application component, since the Angular 19, we would be warned that we should be removing them. So that is almost it for my presentation, but I've got just a little tiny feature for you. And in my opinion, it is something that you should be considering implementing in your application. So this is the trying to connect pop-up that, in my opinion, seriously helps the users on the free internet. In case you lost the internet connection, you will be warned that your application still is trying to connect to some server, and therefore you're able to save your changes that you make in the form. And believe me or not, this one is really simple to implement. All you have to do is to create a service with one status observable that merges two events, online and offline. Also, make sure to pass an initial value of navigator.online and subscribe to the stream. Just during the subscription, you can make whatever you want. So, for example, you can display a toast or some message to the user that he's lost his internet connection. So that would be it from my side. Believe me or not, but sometimes optimizing your application may be a really hard process, and this topic is really deep. Just because it is the top of the iceberg in the world of optimizing the initial load time in your application.
Okay. Thank you, Dawid, for your great presentation. And now let's dive into the Q&A session. So for people online, I just remind you, you can put your questions in the chat. And for those of you who are with us today offline, you can just raise your hand and we'll reach you and you can ask your question.
Oh, thanks so much for presentation. I have a question. Do you compare last version of Angular and previous one for the size and loading time?
So a guy on the site asked whether I compared the last version of the Angular to the previous one and whether it affected the build size. So in my opinion, this shouldn't make a big difference. Often when I compare the two Angular versions, there is just a tiny little difference of a maximum of few kilobytes, which often does not make a really big impact on your application initial loading time. Okay.
More questions?
So, David, like you showed us a lot of like possible techniques, but my question is, if you start optimizing, what is your like way of starting with? How you dig, search, and how you apply the particular techniques?
So that mostly depends at which stage your application may be. Firstly, I would use the lighthouse just to make sure that I am including a few essential techniques of optimizing my initial application. Then often I would go for more powerful tools and check if I load too much JavaScript into my application. But in my opinion, the most important thing of diagnosing why my application may be loading really slowly is to go for the waterfall charts. They basically tell us all of the things that you should know. So for example, whether a particular CSS file may be blocking your application from displaying the screen, or whether you are just loading too much JavaScript. If so, I would often research how I can fix my potential issue. So for example, how I can make the CSS file load faster, or how I can reduce my JavaScript file size even more.
Okay, we have one question from our chat from Amos. How would you optimize icons initial loading without third-party libraries?
So personally, I would use the SVG icons directly, and this is often what could work for the client-side rendered application. In my opinion, this is something that we can do, but on the long term, we should not be using. For example, in cases we have a list that the icon is a particular bullet of the list, in my opinion, in such cases, we would copy and paste the SVG icons, and as a result, we would increase our initial bundle size even more. Therefore, I think often we should take advantage of some of the libraries that are on the market just because using the SVG icons with a tag can often harm your initial bundle. It is not the case if you're using the icons just a few times, but it will be the case in case you are using the same icon in multiple places. So for example, if you're using the same icon in 5 components that are different, in my opinion, at this point, you should consider reusing the icons. For example, you can take advantage of the library that I mentioned, but there are also 2 other libraries that can help you with that issue.
Okay, thank you. We have another question from Bartosz. Will this example of loading a component for Webpack for dialog service also work for ESBuild?
So I also checked this just before this presentation. And unfortunately, this Webpack channelling comment, as of now, does not work in the ES Builder. I know that they're planning to introduce this in the future, but I would not expect this to be anytime soon.
Okay, thank you very much, David. It was the last question, so thank you again for taking the time to join us today.